Hello there, ROS developers, and welcome to this new live class number 123, where we are going to do a little bit of deep learning basics and talk a little bit about neural networks at a very, very basic level. So let's go for it. All right, so welcome everybody to this new live class number 123, where we are going to talk about neural networks at a very basic level. So don't worry if you don't have a good level on deep learning. We are going to do everything at a we're going to keep everything at a very simple level. So yeah, welcome everybody, and let's go for it. As always, remember we are going to be working in the construct application. So I'm going to move right now, because we have introduced one new feature for this live class. I don't know if you have already seen it or not, which is the chat. I will show it right now, but I want to start opening my ROSject for the live class so that I can access the chat. So let's go for it. Then let me very quickly switch here to my computer screen. There we go. So as always, we are going to be doing this live class in the construct. So in case you already have an account, just log in. In case you don't have an account, you can sign up now. It's completely free and it's going to take you just a few seconds. You can also use the social networks login if you prefer so. So I'm going to log in here right now. Then as always, and as we have been doing for the last live classes, we are going to come here to the live classes option. So once you are inside the construct main page, you have to come here to the left area, and this menu is going to hover here. And within this menu, you have to choose the live classes option. All right. So I'm going to click here right now, and here is going to appear today's, let me mute myself. Here it's going to appear today's live class with the current streaming that I am right now doing. Here you have it. And the most important part is here at the top right area, you have this button, this very, very visible button, which is in this very nice light blue color, which says fork and open the class ROSject. So all of you now have to click on this button. And by clicking on this button, you are going to get a copy of the live class ROSject, and it's going to be automatically opened. So let me do it myself here. I'm going to click on the button so that I'm going to get a copy of the live class ROSject, and it's going to be automatically opened, as you can see here. So I want all of you guys to do this right now. Let me open this again and show it one more time. Yeah, so remember, in the main page, you come here to the left menu and select the live classes option. And here, you are going to see the current live class right here, live class number 123, deep learning basics neural networks. And here you have the button in order to fork and open the class ROSject for today. So if you want to get the ROSject and practice with me in this live class, click in this button here. All right, this is going to copy the ROSject and automatically open it, as it has done in my case. Yeah, so here I have my ROSject opened, all right, with the notebook, which is automatically opened for you. And as always, also, well, not always, as in the last live classes, remember that you have also the live streaming here in the same ROSject, so you have everything in the same place, in one single place, all right? So you can have a look at the live streaming and have it opened here in order to follow what I am doing, more or less. But you can follow what I am doing while you are working on the ROSject, which is the main idea of all this thing and why we are doing the live class. All right. Then as a new feature here, we have the chat. So right now I'm going to open it and see the chat. All right. So here I can see the chat. So in order to write messages, you have to write here in the chat. I can see some messages here from Ricardo, Bayode, Marco. Hello everybody. Okay, so very important. Don't use the YouTube chat. Okay, I think I have deactivated it, but I'm not sure. Okay, I'm starting to see now here some messages from Aida Bungur, Prapti Patil. I'm not going to go for this name, too much for me, I'm sorry. But hello everybody. So very important. From now on, we are going to be using this chat for the live classes. It's a self-contained chat of the construct, so we are not going to be using anymore the YouTube chat. All right? I think I tried to deactivate it at the beginning of the live class, but I think I didn't do it properly because I can see some messages here in the YouTube chat. But very important, all of you guys switch to this chat and start writing here in the live class chat. All right, this one here, the one that I am showing right now. Okay, Ruben Alves, Thomas Peirukain, Aditya Nerpagar, Ricardo. YouTube chat is not deactivated. Yeah, I have just seen. It has not been deactivated. Okay, this chat, Rarenj Malenberg. Yeah, so all of you guys, please keep in mind to write in this chat, okay? Let me try to... It looks like this button is not... Okay, in any case, let's come back here. All right, so have you been able to copy and open the ROSject? Yes? So are you in the same state as I am here with the ROSject opened, the live class here with the chat opened at one side, also the Jupyter notebook opened with the proper ROSject, which is this one, live class number 123. Okay, I can start seeing here more messages. So looks like everybody is coming to this chat. Hello. Yes. Okay, perfect. So if everything is working fine, and you have already your ROSject opened, let's go for it. So, in today's live class, we are going to be working on deep learning basics and specifically on neural networks, as I have said before, on a very basic level. So, why this live class? Well, because we have just published one new course in our academy, which is Deep Learning for Robotics. I have left you here a link so that you can click it and go have a look at the contents in more detail of this course. What are you going to learn in each unit, etc., etc. Very interesting course. So that's why today we are going to do this first introduction to deep learning on neural networks in order to give this first step into deep learning, which sometimes sounds a little bit scary. It sounds like something super complicated, but so today we are going to try to do this first step so that you lose this fear to deep learning and neural network, which sound super big, and yeah, to let you know that we have this new course, deep learning for robotics in the academy. All right, then we are going to be working with a simulation, of course. So the first thing we are going to do is to launch our simulation, all right? Then, in order to do so, very simple. First of all, we have to open a new web shell. And how do we do so? Very easily. Here in the bottom bar here of the ROSject, you are going to see different options. Then here, the first one, starting from the left, is the web shell. So if you click here, this is going to open a new shell, which is basically a regular Linux shell where you can type Linux commands. So you are going to open a new shell, as I have just done here, and then we are going to run this command, the command that we have here in the notebook, which says ROS launched Turtlebot 3 gazebo, Turtlebot 3 empty world.launch. All right? Yes, yes, Jupyter Notebook is still loading. Okay, let's see if maybe Ryan, you can try to refresh it here or something. By the way, let me say one thing, because let me tell you that I am not liking very much this chat right now, because I see too many people without pictures. So let me just do a quick reminder. If you want to show your beautiful face here and see it appear here in the chat, you can update your project here in your ROSbach account, okay? So you come here to your profile and you can, you can update the picture amongst many other things. So you can also update your profile, you can create your own curriculum here. So have a look here at this, so that we have a better chat and a more beautiful chat, because right now I can see too many people here with this question mark in his face, which personally I don't like very much. So I really encourage you to come here to your profile, have a look at it, and update your picture. And of course, you can also update your online resume, yeah, with your ROS skills, your work experience, etc., which is going it's going to make your profile more visible and more interesting, for instance, for enterprises, which might come here in order to hire you. So have a look here to your profile and update it. But for now, just update your picture so that the chat is better, and you will see all the other features later when the live class finishes. All right, so let's come back here. And yeah, so we need to execute this command here in order to start the simulation. So we can write it here letter by letter, which I don't like very much this option. So what I'm going to do is to just come here to the notebook and copy directly the command with Ctrl+C. I'm going to copy it directly from the notebook and paste it here to my web shell with Ctrl+V. Okay? So I copy and paste it in order to save time. It's much more faster. And then I'm going to execute it. So now Gazebo is being launched. And this is going to start the GC server, also the GC client, in order to provide me the simulation. But right now, in order to visualize it, so right now the simulation is there, it's running. So the GCZ server is there running with the simulation loaded. But in order to visualize it, we need to do one more step, which is to click on this cube-like icon, as it is explained here in the notebook also. This cube icon, we have it also here, as you can see, in this bottom menu. So I'm going to click here, and this is going to open the client in order to visualize the simulation. Here we are going to see it right now, and here I have it. All right, so here I can see my simulation with the Turtlebot 3 robot there in the center. And this is the simulation that we are going to be working with today. Yeah, you can see a picture here of what you should expect to see in this simulation. So yeah, basically right now, we have finished it here with the setup. So you should have something similar to this. Yeah, you should have the Jupyter Notebook open it here on the neural network section, which is what we are going to start explaining right now, and also here the simulation loaded. So are you in this state, all of you? Yes, no? Have you reached this point? Did you get lost in the way? Do you have any question? Let me know here in the chat. Yes, yes. Okay, by the way, I start to see more pictures here on your profile, so I really like that. I see that you followed my advice. So right now here, the people with pictures is almost winning the people without pictures. Huh? So we are starting to outnumber these question mark people. Hello, just arrived. Did I miss something? I try to keep up. No, Lucas, nothing important. So far we have been doing all the setup. Right now we are ready to start with the live class itself. Yes, everything running. Okay, so everybody is set up, then let's go for it. So, as I have said at the beginning, we are going to be talking about neural networks, all right? By the way, let me tell you that you can organize all this as you prefer, okay? In case you want to have a bigger notebook, you can make it bigger in order to better read everything. You can move it here to the right and reorganize everything as you prefer, okay? You can set everything up in the way you are going to work better and you feel better. So let's go for it. Then neural networks. So basically, a neural network tries to imitate a human, or more likely an animal brain, let's say. So the goal of a neural network is to map some input data into an output data. So given some input data, the goal of a neural network is to try to predict what the output is going to be. Yes, using some connections and some weights that we are going to see in a moment. So basically, a neural network is a construction of interconnected nodes, which are also called neurons or perceptrons, that recognize relationships in a data set. So we are going to have to input a data set. This is an important point. So we are going to have to input a data set into a neural network. Yeah, then with this input, we are going to produce an output. Yeah, so always very important to keep in mind this relationship between the input data and the output. Yeah, this is the main thing and the main goal, which is something very easy to understand. So the main goal of a neural network at the end, even though inside there are many processes, the goal is to produce an output from an input data. All right? So here we have a small image which shows the structure of a quite basic neural network. So here we can see all these circles which represent different neurons. You can see also that each of these neurons has a different color. So, for instance, we have here in pink the input. So this is, we can call here the input. It is also known as the input layer. Okay, this is where we are going to input our data set. So the data that we want to get an output from, we are going to input it here in the input layer. All right, then we are going to have the output layer, of course. Our goal always is to produce an output, remember this. And in the middle, we are going to have this layer, which is known as hidden layer, all right, which is basically the one that is going to do all the work. Okay, we are going to see a bit more of this process in a moment. So basically what we are going to use is these W values that you have here, which are weights, okay? So we are going to combine these input values with some weights, which are going to produce an output value. All right? Then, depending on the output, if it is good or it's not good, we are going to recalculate these weights and keep improving them in the process. All right? That is what is known as learning, because we are going to keep improving the process of the learning. All right? Then, so here we can see we have the input layer, which of course can has as many neurons as you want, any number of neurons. It is going to depend on the task that we want to achieve. All right? In the example of today, for instance, you are going to see that it is going to have only one neuron. So it's going to be a very simple example, but this can have any number of neurons. The same as the output layer. Also, it can have any number of neurons, depending on the example. So for instance, here we have an example which is a picture. If we want to analyze a picture, then the input layer should have as many neurons as pixels in the image. All right? So everything depends on the problem that we are going to attack. Yeah? So basically, before attacking a problem, you should analyze it and then decide and design your neural network. So you are going to design and decide how many neurons it is going to have each layer, etc., etc. All right? Then we have the weights, as we have seen also, which basically are the values of the connections between the neurons. All right? You can see this quite simple mathematical formula where we are going to be multiplying all the input values, which are these x values. Yeah, we are going to be multiplying these input values for weights. All right? I am in the neural network notebook section. Did I miss something? Not much, Andrea. No, as Bayode says, not much. By the way, let me know. Are you feeling some kind of delay in the live chat from when you write a message to when you see it here in the live stream? Are you noticing some delay or not? Let me know here because I am interested in this data. About 9 seconds delay, says Ryan. Nope, nope. Okay, so it looks like it's going pretty well, because this was one of the problems that we had in the YouTube chat, by the way, that the delay was super huge, but super huge. So hearing that the delay is much lower now, it's a very good thing to read. So great. Okay, then let's keep going. Yeah, we have also a bias here, which basically is going to allow us to add some non-linearities into the calculations, okay? Because as you can see here, this formula is linear, all right? So here, the bias is going to allow us, which is represented here, is going to allow us to introduce some non-linearity into this equation, okay? However, we are not going to go too much deep into this now. So finally, the hidden layer, which is the one that we have here, hidden layer, the yellow one, is going to compute the sum of the weighted input values. Yeah. So these operations, the sum of the input weighted values is going to be computed into the hidden layer. Of course, networks, these neural networks can have multiple number of hidden layers with multiple number of neurons in them. So in this example, we have only one hidden layer, but we can have multiple hidden layers. Again, this is going to depend on the problem we want to attack. So usually the more complex the problem we want to attack and the more complex the data we want to analyze is, the more neurons we are going to need, the more hidden layers we are going to have to use, etc., etc. All right? Okay, then having done this brief introduction, so in order to create a neural network, basically we are going to have to complete 3 steps that we have here, very briefly explained. One is the design of the neural network that we are going to use. The second one is the training of the neural network. And finally, the prediction of a neural network. There are the 3 main steps that you are going to have to complete when working and when creating a neural network. Okay, so let's have a quick look at these 3 basic steps and try to understand very easily what they do. So, first of all, as we have been saying already, the problem that you are facing, that you are going to face, and that you want to solve is going to define the number of neurons that we are going to use. Yeah, so usually the more complex the problem is, the more neurons we are going to have to use. All right? So, in the design, let's try to keep only this sentence, which is very important. So the number of hidden layers and neurons on them will depend on how complex you want your model to be. Okay? But not only of the hidden layers, of course. So depending on the problem, we are going to have more neurons in the input layer, more neurons in the output layer, etc. Okay? So, first of all, in the design of the neural network, basically you're going to have to analyze your problem. So which data you are going to receive? Are we going to receive, I don't know, maybe we are going to receive a position with the values X, Y, and Z of your robot, for instance. So if your data is going to be that, you are going to have to use a certain number of neurons, right? If you are going to receive an image, then you are going to have to use a much higher number of neurons in the input layer, in this case. Yeah, in the input layer, remember the input layer is the layer where we are going to basically put our data, the data that we want to analyze. All right? So, second is the training of the neural network. This is the next step, all right? So once we have analyzed our problem and we have designed the neural network we want to use, then we are going to proceed with the training of our neural network. So in this step, basically what we are going to do is to map input values into output values. So given a data set, yeah, so remember also this, we are going to need to have this data set at the beginning. So we are going to start mapping input values into output values. Okay, so the input values, we know them, right? And we also know the output values. At least we are going to know the expected output values, right? You are going to understand this better in the example, but these values, the input, of course, this is obvious, but also the expected output that we are expecting to have, these values, we know them. So the values that we don't know are these weights and the biases, are the values which are in this hidden layer. These values, we don't know them, all right? So this training process is going to consist of feeding the network with X values, then performing operations with random W and B values, and obtaining an output result. Then once we have this output result, we are going to analyze how far this result, the result that we have obtained, how far this result is from the result that we are expecting to have. Yeah? So imagine, for instance, that we are moving our robot. Yeah, imagine that we are moving our robot here forward. Yeah, so imagine that we are moving the robot forward in this direction. Let me show it here like this. We are moving the robot forward at a speed of 1 meter per second, linear speed of 1 meter per second. Then, after 1 second, which is the position that we are going to expect to have our robot after 1 second, assuming that it is starting at the 0 position? Can somebody tell me here this super basic problem? So our robot is starting at the 0 position in the x-axis, let's say, and it is moving at a velocity of 1 meter per second. So after 1 second, where should we expect to have our robot? One meter, that's it. So we are going to expect to have our robot 1 meter, yeah? Each of these squares, by the way, is 1 meter, okay? These are square meters. All right, then imagine, so we know the input information and we know the expected output, okay? Then knowing this data, if we introduce it into our neural network and our imagine that we introduce all this data into the neural network and the neural network says that the robot should be at the position 2 meters, right? So if this happens, we know that the neural network is wrong, right? So his answer is not correct. Then we are going to know this difference between the neural network output and the expected output as the error. Okay? Then there are many different ways of computing this error, etc. But for now, just keep in mind this. So the difference between the neural network output and the expected output, we are going to know it as the error. So our goal in the training process, our goal is going to be to lower this error as much as possible, right? This is our goal, that this error is as low as possible. This is going to define how good the training of our neural network is, all right? So, all right, so some more things here, yeah. Yeah, here, so the process of comparing the result of the network with the expected value is called error computation. This is what we have said right now, which will likely decrease once you start iterating to find better values for W and B. Yeah, so of course this error is going to be determined by the weights and the bias. Of course. Yeah, so our goal is going to be to lower as much as possible this error, so to find the better weights and bias for our neural network, right? Then the final step here is the prediction step. So the goal of our model or the goal of our neural network, as we said at the beginning, is going to be to obtain outputs from previous unseen inputs. Then these outputs will be the probability that, given an input, the output is the expected one. All right? So this is, again, the same idea. Then finally, so once the difference between the result and the expected values are low, the values for W and B are stored. So once the error, here what this means is when the error is low enough, once we consider that the error is low enough, then we are going to store the weights and the bias. These values for W and B are going to be stored. And then we can start using this model for prediction. Then we are going to feed the network with unseen input data and expect it to give us a reasonable output value. All right? Make sense all of this in general terms? Do you see the general picture? Probably there is people here in the chat that has a much higher knowledge already on deep learning, so this is going to be very basic for them. But for the people who is new, does all this make sense? Do you see the general idea of a neural network? Yeah, says Shivan. Yes. Okay, great. Andrea also, yes, makes sense. Excellent. So the idea, as you can see, it's pretty simple. Yeah? So the general idea is pretty simple. Then, let's go for it. So let's start with some practice right now. So for this, we are going to be using our simulation, of course. And we are going to store some data, right? We are going to execute a script, which is this one, moveVelocity.py. Then this script, you can check it if you want in the IDE. So another of the options that you have here in the bottom menu is the IDE, the code editor, all right, which is right next to the web shell option here. Then if you click in this code editor, you are going to be able to see with a graphical interface all the workspaces and files and folders and everything that you have here inside this rosject. So in this case, everything that we are interested on is here inside the Catkin workspace. So you can open this Catkin workspace and open the SRC folder inside. And here you are going to see this DL repo folder. You can open it. And also inside this DL repo, you can open the move robot package that you have here. Okay? And finally, here inside the move robot package, we have the SRC folder. Here we have different scripts. So in this case, the one that we are going to use is this move velocity.py. Move_velocity.py. Okay? So I'm going to open it and show it very quickly, but we are not going to go into this. So basically, this is a very simple Python script that is going to start publishing velocities into the command bell topic in order to move the robot forward, and also it's going to store, in this case, the odometry data, which is not important. Basically, what it's going to do is to make the robot move. In this case, it's going to make the robot move in the x-axis, so it's going to move forward only. Okay, we are not going to apply any rotational velocity or anything. So, what are we going to do in this case? We are going to start by recording the odom data, okay, using the ROSbach command. Do you know, guys, this ROSbach command from ROS? Basically, this is going to allow us to store the data from a topic or for many topics. It can be used for many topics. In this case, we are going to only store the data. We are going to record the data of the odom topic. The odom topic, we can have a quick look here at the odom topic, basically contains data about the position of the robot. Okay, ROS topic echo odom. If we execute this command, you are going to see the messages that are published into this topic. Basically, you are going to see that we are going to be able to store data about the pose, which is the position and orientation of the robot, also about the twist, by the way. But in this case, we are going to only be using the position data. Okay? So we are going to start by running this command, ROSbach Record odom. Okay? Then this is going to start recording all this odometry data into a file. Okay? It's going to start saving all this data into a file. Then once we are recording this data, we are going to run our Python script move velocity so that the robot starts moving. Okay? So let me do it. Let me start here by running this command, ROSbach Record odom. So, by the way, let me not do it here, because I am not following my own instructions, which tell me to go to the Catkin workspace SRC folder. Yeah? Why this? Because the file with this data is going to be stored where I am running this command. As you can see, this back file has been stored here. But I don't want it here, actually. I want it inside my Catkin workspace SRC folder. So I'm going to first run this command in order to move there, and then here I am going to start recording. ROSbach Record odom. Okay, there we go. Let me open another shell. So I'm going to start recording. There we go, subscribing to odom topic and recording to this back file. And now I'm going to run my Python script in another shell in order to start moving the robot. So now we are going to see that our robot is going to start moving. There we have it. It starts moving. You can leave it moving a little bit in order to keep storing and recording the data. And at some point, we can just stop recording. Let me stop it. And let me also stop the script to stop the robot. There we go. See, the robot has stopped, and I have stopped the back file, which has stored all this odometry data that we have been recording during these seconds into this file. 2021, it has the date and the hour, .back. Okay, you can do an ls and you are going to see it here. Also, of course, you can access and have a look at this file on the IDE. Okay, so if we come here to the Cacking Workspace SRC folder, we are going to also see this file. If you open it, basically you are going to see that it has some data here which is hard to read, let's say. Yeah, it's very hard to read and to understand this data. So one thing that we are going to do right now that we have this back data, we are going to convert it to a CSV file. Okay? Because why? Well, because as a CSV file is going to be much more easy to process. Okay, and to feed it as input to our neural network. So very easily, in order to convert this back file into a CSV file, we have to execute this command here. Yeah, we have it also here in the notebook. So I'm going to copy it and paste it directly here. The only thing that you have to keep in mind is that this back file name is not the correct one. Yeah, this is just an example, back file. So here, what we should do is to come here to the name of the back file, remove it, and actually put the name of your back file. The one that you have recorded and that you have here, you have to put this name. All right, put this name instead of the one that it is here in the notebook. Or you can just put start putting the date number, which is 2021 in this case, and then you can click on the tab key of your keyboard, and this is going to automatically autocomplete the name of the file. Let me show it. I'm going to click right now on the tabulation key, and as you see, this autocompletes the name of the file. Okay. So right now, by the way, I see that I already have a velocity data here. So what I'm going to do is to remove it, remove this one, so that I don't have it. Okay, now I only have the back file. Okay, and now I'm going to run my command to generate this velocity CSV file. There we go. It starts converting the file, and now if I do an ls, I'm going to see that I have this velocity data CSV file. Okay, so now we can also have a look, if you want, to this CSV file. We can open it. We have it, by the way, we have it here, velocity CSV. And you are going to see that now the data is much more organized, let's say. Okay, it's still hard to understand, but you are going to see that it's much more organized. So we can see here all the fields with the header fields. I cannot move here, by the way. Oh yeah, here. Yeah, I wasn't seeing this bar. Yeah, we can see here that we have all the different data fields defined, the position in the x-axis, for instance, the position in the y-axis, z-axis, etc. Okay, so basically now I have all the data organized in different rows, columns, etc. I didn't realize it was this easy to convert back files to CSV. Yes, it's pretty easy. With this command, it's super easy. So, all right, then, now that we have generated our CSV file, we are going to feed this data. We are going to use this CSV file as our data set, all right? And what are we going to do with this data set? Can somebody tell me? What are we going to do with this data set? Let's see. Somebody tells me in this chat, okay, I have this CSV file, so what should I do now with this? What do you suggest me to do with this CSV file? Use it to train a neural network. All right. So at the beginning of this class, we said that in different parts, we said that we want to input data in order to get an output data. This is the main purpose, all right? So, usually a neural network is given an input and an output. Its job is to learn the mathematical information between them, imitating the human brain operations. Okay, we have the input layer. Yeah? So, what we are going to do right now, as you are saying very well here in the chat, is to use this data that we have in this CSV file. We are going to use as the data set for our neural network. All right? But before that, we are going to have a quick look at this data. Yeah? Very quickly. So we are going to create a new file, which we are going to name plot_pos.py. Okay? I'm going to create it here using the IDE super easily. So for instance, let me create it here inside the SRC folder. I'm going to right click on this SRC folder, new file, and I'm going to name this plot_pos.py. Okay, this is going to open this file empty here in my IDE, and all I need to do is to copy and paste this data that we have here in the notebook. Okay, so very easy and simple script. Let me show it quickly here. So basically what we're doing here is, as you can see, we are reading this CSV file, the velocity data CSV file that we have just generated. We are reading it, and then we are putting all the data into a plot using matplotlib. In this case, we are using matplotlib in order to generate a plot. Okay, so we are taking into account, in this case, we are going to plot the stamp, which basically is the time, and the position in the x-axis. We are going to plot these two values. All right? So if we run it, let me run it very quickly. Python plotpos.py. Let me run it. And what is happening? Nothing. No. It is happening something, but we are not seeing it. So, okay, so the plot has been generated, but in order to visualize this plot, we are going to have to open the graphical tools. Okay, so the graphical tools, we can access them by clicking on this icon here in the bottom menu also, that is looking like a computer. Okay, this one here. If we click it, it is going to open the graphical tools, and here we are going to be able to see this data, the data that we have in our CSV file. We are going to see it here as a plot. Okay, so at the beginning, we can see here in the left axis we have the values of x, and in the bottom axis we have the values of t, of time. Okay, so we can see that our robot started at the x value 1. Yeah, why? Because we started our robot from here. Remember that at the beginning I moved it for my example, and I left it here at the 1 position, more or less. So that's why the plot here shows that the initial value of x is 1, and is 1 for some time. It keeps constant in this position for some time. Why? Well, because I didn't start moving the robot immediately, right? First of all, I started recording. Do you remember? I started recording, first of all, with the ROSbach command, and after some seconds, then I started running the Python script in order to move the robot. So that's why I can see this plot here. So at the beginning, the position remains constant at 1, and then when I run the script, the position value starts to increase with the time. Yeah, makes sense, this plot? So basically this is the behavior that we have seen in the robot. Yeah, so nothing strange here. But usually it's always nice to visualize this kind of data in plots. Yeah, rather than having to check the CSV file or whatever. This is very explanatory to visualize all this data in plots, and it helps a lot to analyze. All right? Okay, then let me minimize this. Let me stop this script to stop the plot. And now, as a final step, we are going to actually use this data. we are going to feed it into our neural network. Okay, first of all, of course, we need to create our neural network. So in this case, the neural network that we have designed and that we are going to use is going to be this one. Yeah. So remember this first image that we saw. So basically, analyzing our problem, we can design a neural network which looks like this. So basically what I want to know is the position of my robot in a future time. Yeah? So I know that in a certain period of time, which is the period that I have been recording, let me run this again, by the way. Yeah? So I have the data right now from this timestamp to this one, okay? But what is going to be the position of my robot in a future timestamp? What is going to be? So this is what I am interested to know in this case with this neural network, okay? This is a very simple example. So all I want to know is the position of my robot in the future. What is going to be the position of my robot? I want to know it. I want to predict it. All right? So for this, I'm going to use this neural network. Then, in this case, I can design a very simple neural network. It's going to have, in the input layer, only one neuron. So I'm going to input the time. Okay? And as an output, I'm going to check the X position. All right? And in the middle, I'm going to have the hidden layer with the weights and the bias. Okay? So with this neural network, I want to generate a model that can predict the X position of my robot at any time in the future. Yeah, this is the goal. This is the goal, to be able to get the position of my robot, the X position of my robot, at any given time. Okay? Then for this, we already know the time, and we know more or less what is going to be. We can know what the output is going to be also. Okay? Then, generating this relationship, we are going to be able to compare the neural network output with the predicted output, with the expected output. Yeah, the output that we expect to receive. Then, let's come back here. Okay, so the code that we are going to be executing in this case is this one. You can find it here in this path, catking workspace, src, dl repo, dl exercises, unit2 underscore exercise1.py. So let's come here to the IDE and go to this path. So dl repo, dl exercises, unit2 exercise1.py. Here we have it. So I'm going to open this file, and here I have the code for the neural network that I'm going to be running right now. Okay, so let's have a quick look here at the neural network code, which is pretty simple. So let's have a look. What we are doing? Okay, so first of all, we are reading here our CSV file, the velocity data CSV file that we generated. Yeah? This velocity data CSV file that we generated at the beginning, we are reading it. Okay, and we are interested in the stamp, which is the time, and the position X. All right? Then here we have the main function, the function where we are defining our neural network. So first of all, we are going to define our model as a sequential model. What is this? Well, this is just a type of a model. I have added down here some nodes in case you want to get some more data. So a sequential neural network is a model which basically it's useful and appropriate for neural networks which have one input tensor and one output tensor, which is our case. Yeah. So in our design we have one input and one output. So this sequential model is appropriate. If the neural network is more complex, then probably you are going to have to use other models, okay? In this case, we are using this sequential model. You can learn more here if you want, of course, and in our course, of course, which all this is better explained. Then once we have defined our model, we are first of all, let me come back here to the code. We are adding the layers. So first of all, we are defining here the hidden layer, which is going to have one neuron, which is defined here in the units variable. Yeah, this units variable defines the neurons of the hidden layer, okay? And also, we are defining the input shape, which is 1. It has only one column, and we are going to use bias. And here we are defining the output layer, which in this case is going to have only one neuron also, okay? So it's going to be a pretty simple neural network. Then here we are just generating a summary of our neural network to print it in the shell. Then we are compiling it here. We are using as loss function the MSE, which is the mean squared error. I have also added here in the notebook another link to better explain this mean squared error. But basically, this is one of the methods that we can use in order to calculate the error that we were talking about in the beginning. Yeah. So the difference between the output given by the neural network and the output that we would expect can be calculated using this mean squared error. Yes, and then this is what we are going to use as a metric in order to try to optimize it. Yes, so the lower this MSE value is, this mean squared error value is, the better our neural network is going to be. All right. Then finally here we generate our training. In this case we are going to use 500 epochs, which is going to be the number of repetitions of the training that we are going to have. We are going to see it in a moment when we run it. And finally we are going to return our model trained. Yeah. So once it has finished, we are going to return our model trained. Okay? Let me go back to the code. Sorry, here. We are going to return our model trained. Then, here, so once we have our model trained, in this variable, here basically what we are doing is to generate the predictions and the original data. Okay? So we are going to load the original data that we have, and we are going to load as well here the predictions. Yes? So using our model, we are going to predict the positions in the future. Okay? And then finally, once we have the predictions of our neural network and the original data, we are going to plot both of them. Okay? We are going to plot both of them, both the original data and the prediction of the neural network. All right? So let's run this command right now. Since we are running out of time, let me run this command right now. And in order to run it, we can use this command that we have here. Yeah, Python 3 catkin workspace src dl repo dl exercises unit 2 exercise 1. I'm going to copy it directly here from the notebook. Let me copy it and paste it here into my web shell and run it. Let's go. Okay, so I am running right now this script here, the one that we have just reviewed. I am running it here. So this is going to take a bit of time in order to generate all the neural network, load the datasets, etc., until it starts with the actual training process. Yeah. So here it's loading TensorFlow, as you can see. Okay, and here it is printing the summary of our neural networks with the shapes, layers, etc. And here it's starting all the epochs. Yeah, you see here epoch 50 of 500. Here it is running all the epochs. Okay, 150. So once it reaches the epoch 500, it's going to stop. Okay, as you can see, it is showing us the loss and the mean squared error for each epoch, which in this case it's the same because we are using the mean squared error as the loss function. Yeah, you can see it's the same in this case. Okay, so this keeps going. It's going for the epoch 280. You can see here the errors, etc. Okay, 400 epoch already from 500, so it's almost finished. And there we go, it has finished, okay? Epoch 500 out of 500. So now, also in our graphical tools, as we saw in our script, we are plotting the original data and the predict data. So let's go to the graphical tools and we are going to see this data here, which actually it's not good at all, right? So basically this is the prediction that our neural network is doing right now of the positions in the future. Right? However, in this case, 1, 2.5, this data, though, this one here doesn't make much sense. But well, here basically is the prediction that our neural network has done. So basically, we can see that it's not much accurate at this point, right? It makes some kind of sense because it thinks that it's going to have a constant velocity which is going to keep growing, which is very similar actually to the data that we have in the original. Yeah. So it's following more or less this same idea. Yeah. So the position is going to keep growing with the time, more or less at a linear with a linear progression. Yeah. So yeah, damn. Now I have just okay. Let me just create. Okay, then for instance, we can modify here the number of epochs. Of course, we can modify the number of neurons here in the hidden layer. We could add an extra hidden layer if we want. In this case, let me just run a very quick training here in order to get again the final result, but not having to wait for the 500. There we go. Actually, in this case, I don't think there is going to be too much difference. There we go. Okay, yeah, so you can see here, it's a bit worse, the prediction, as you can see. Yeah, it's a bit worse, the data. So probably if you increase a lot the number of epochs, this result is going to be much better. Okay, so I encourage you to do it. Try to modify here the number of epochs, put a very high number, I don't know, test with different numbers and see how this affects the predictions of your neural network. Okay, try modifying the epochs here, try modifying also the neurons used in your layers. You can try adding extra layers also and see how it affects the training process and the results that you obtain. Okay, so yeah, that's it. So basically that's it. I hope you have enjoyed this live class. We are already past in time. What defines the number of episodes? Well, generally what defines the number of episodes is going to be the same that defines the number of neurons and hidden layers that you are going to use, which is the complexity of your problem. Yeah. So the more episodes, usually the better results you are going to get. Okay. In any case, there is going to be one moment which more episodes it's not going to mean better results. However, okay, but these are more advanced concepts. So in order to keep it simple, I hope you have got a good general idea of neural networks, at least this first step that I was talking about at the beginning. And in case you liked this live class and you enjoyed it, I encourage you to go and learn much more. Yeah. So as I said at the beginning of the live class, we have our Deep Learning for Robotics course, just published it yesterday in the Academy, so you can have a look at it, or keep investigating on your own, whatever you want. All right, but this is just a very, 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 very little taste of deep learning and of neural networks. Of course, there is much more to learn and much more to see. So yeah, for this live class, I'm going to end it here. Then thank you very much, all of you, for being here with me in another live class. I will see you next Tuesday with next live class. And until then, as always, take care of yourselves and keep pushing your ROS learning. Bye-bye. See you.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises, a fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.